Hi, I'm Jay Hartenbach,
And I'm Matt Fertney.
and we're engineering students at the University of Miami in the Biomedical Engineering Department.
This is a video about how to use breadboards as part of the video series from Dr. Zhao's Biomedical Measurements lab.
I hope you enjoy the video and you learn something from it. Thank you.
A breadboard is a construction base for a one-of-a-kind electronic circuit, a prototype. Today, the term breadboard is commonly used to refer to the solderless breadboard. Because the solderless breadboard does not require soldering, it is reusable. This makes it easy to use for creating temporary prototypes and experimenting with circuit design. Older breadboards did not have this property. A variety of electronic circuits may be prototyped by using breadboards, from small analog and digital circuits to complete CPUs. A breadboard is made of a series of rows and columns. These columns are often used for your ground and power supplies. There's a break right here in the columns. This is very important. A lot of beginners will make the mistake of thinking that the node runs the full length of the board. If you want to connect these two nodes, you'll need to use a wire to bridge the gap or the break in the node. The rows are set up with 5 plugs all in a row. Each row is one node, and the next row is a separate node. This is another node. This is another node. This is not connected. So there are 2 nodes side by side, and it goes all the way down the breadboard like that. This can be useful if you want to connect an element of your circuit to 2 separate nodes. Then you can connect another element of your circuit to the same node. Right now, these 2 capacitors are connected at this node. Another way to do that would be to use one of these nodes over here. You can see that the capacitors are connected at this node, but not here. This is a separate node from this node. Binding posts on the breadboards are useful for connecting your prototype circuit to other equipment in the lab. The binding post has a hole right here that you can put a wire into. You plug the wire in, and then you screw down the clamp. Once the wire is secure, you can plug it into one of the vertical column nodes or any other node on the circuit. You can then take a wire with an alligator clip and plug the wire into the binding post. This provides a firm way to plug your circuit into a power supply or other device. Here I demonstrate how to build a basic circuit. This circuit is a resistor-based circuit with 3 resistors. Note the placement of the resistors. The 2 resistors on the right both share nodes. In the middle I use a row, and all 3 resistors are connected to this row. Here I show how to wire your circuit to the binding posts. Be careful with your wire placement, keeping your wires out of the way to avoid confusion. And remember, always connect your power supply last. That way, you don't risk damaging your circuit. Next, I will show you how to build a slightly more complicated circuit. This circuit is known as a bandpass filter. For the bandpass filter, I will use 2 resistors and 2 capacitors. I will use one of the columns as the grounding node, and I will use the rows as my other nodes. Always be careful with placing your components so that you don't bend the wires on your resistors or capacitors. Once your circuit is complete, you can connect your circuit to the binding posts. You don't always have to use binding posts, but they're a convenient way to hook up your power supply quickly and securely. Lastly, I will demonstrate how to bridge the gap in the node on the column, right there. By putting a wire in to bridge this gap, I can connect my grounding node to the other side of the circuit. Here's a close-up view. Once you have finished building your circuit, you can connect the power supply. When you connect the power supply, be careful that the positive and negative terminals do not touch each other. Otherwise, your circuit will not get power and it will not work.